Okay, guys. So today I would like to actually teach you about how to balance half equations and then get an overall equation related to redox reaction. For this part, I'm just going to actually show you the normal method, which is going to be using half equations, and we try to balance the equation. So here I will show you two examples related to redox reactions where we can use the half equations to solve and to balance the equation. So here, okay, we have this transition metal, okay, being reacting with acidified dichromate ions. Okay, so they say that M2 plus has reacted to form M4 plus, and then they mention that acidified dichromate ion. So this is dichromate ion, and it is changing into Cr3 plus. So our task over here is to write the half equation involving this. Okay, so here I think it's quite simple. When you have M2 plus to become M4 plus, so what we need to do is M2 plus has lost 2 electrons to give you M4 plus. So lost electrons, so we bring it to the right hand side, it's going to be 2 electrons over there. So M2 plus has lost 2 electrons. So the first half equation is done. Okay, it's done. Now we will focus on the second half equation, and which is going to be a bit requires some process. So I will actually write it here a bit. Hold on. So I will write down Cr3 plus. So the first thing that I'm going to do is, okay, we have Cr2. So you just put the 2Cr over there, okay, 2 in front of Cr3 plus. So because of the 2Cr over here, okay, now it's a bit balanced. But the only thing that we have over here is on your left hand side, there's oxygen. So we need to have oxygen here. Okay, the presence of oxygen here on your right hand side, you might think, okay, should I actually put O2? Okay, but again, do remember the reaction involving dichromate do not give you oxygen. Only few reactions in chemistry gives you oxygen gas, O2. Okay, for example, reactions of decomposition of hydrogen peroxide, electrolysis, and so on. So in this, to cut this short, okay, when it comes to dichromates, okay, they do not actually release oxygen gas. So how do we get oxygen? Okay, so this is the part that the acidic, okay, acidified dichromate will come in. Okay, because this one, okay, it will actually give you the oxygen in form of water. Okay, now if you have in form of water, okay, you can ask me why on my left hand side there is no water, hydrogen. Yeah, so that's the part where the acidified, okay, acidified dichromate comes in. The acidified dichromate actually has H plus. So now we have something like hydrogen ions and so on. So we try to balance, okay, the half equation. So on my left hand side, okay, I do see I have uh, 7 oxygen. So what I need to do, I need to make sure that I have 7 oxygen here, okay, on my right hand side. So on my left hand side I have 7, so right hand side I put 7, but that makes me to have 14 hydrogen. So I just need to put 14 over there. The last part that we need to check is going to be the charges, because we didn't actually put the electrons over there. So the charges we have to balance. So here I have -2, okay, -2 as my charge. 14 times +1, so you are going to get +14. That makes the overall charge to become +12. That's going to be on my left hand side. So here 2 times 3, okay, I'm going to get +6. 7, water is going to be 0 charge, so 0. So I'm going to have +6. So my aim over here is to make sure my left and right is balanced. It means I must have the same charges. So I will introduce electrons, because electron carries -1 charge. So if I introduce 6 electrons, okay, that will actually add with -6. That will actually make me 12 minus 6, I will get positive 6. So your left and right is balanced. So that makes me having these two half equations, which I have balanced. And what I'm going to actually do now is to actually combine the two half equations so that I am going to have an overall reaction. Okay, so the overall ionic equation. Okay, so what we have over here is, okay, I have 2 electrons here, I have 6 electrons here. What we need to do is we need to eliminate the electrons. Okay, do take note, the electrons on my first reaction is on my right hand side. This is my right hand side, and then the electrons on my second reaction is going to be on my left hand side, so they will get cancelled when I add these two later. So what I need to do first is I need to actually times, okay, I need to multiply the 2 electrons so that you get 6 electrons. So how do I do that? I times everything by 3. So 3, and then 2 times 3 is going to be 6. I will have 6 here. So what I'm going to have now, I can actually, I have 6 electrons here. So what I will do now, I will combine this equation 1 and equation 2. So the electrons will cancel. So I will get some like this, Cr2O7 2 minus plus 3M2 plus 14H plus. Okay, and the electron, 6 electron has been cancelled, and you will have 3M4 plus, okay, plus 2Cr 3 plus 7H2O. So this is going to be the balanced ionic equation that we will obtain. So please, what we can do now is to just double check, okay, whether what we have, okay, is actually matches with what we have written over here. So you have, okay, 14H plus, yes, and I have 3M2 plus. So we just need to look for 3M2 plus and 3M4 plus over here, and the rest are the same. So the answer for this question is going to be C. So the same thing, if I want to apply this way, okay, to solve, let's say for another example, let's say we have a reaction, okay, with acidified potassium manganate and Fe2 plus. So how do I use the same method to solve this situation? Same, okay, you need to have half equations. So I have Fe2 plus, okay, Fe2 plus, acidified potassium manganate is going to be a good oxidizing agent, so it's going to change into Fe3 plus. So that is what I want to obtain. Okay, so let's say it's also given, yeah, the reaction is giving you Fe3 plus. Let's say they have mentioned it to you. If you're confused, okay, they have mentioned it to you. What we need to know, okay, as much as possible, when you have Cr2O72 minus, they you need to know they will change into Cr3 plus. In this question, they have mentioned it. But sometimes, okay, when you are using potassium manganate, okay, they have manganate ions, okay. So these manganate ions, okay, they will not tell you, okay, what will they give you, but you need to memorize this, okay. Manganese manganate ion, okay, they will actually give you Mn2 plus. Okay, these are the two important things that we need to come up first before trying to balance the reaction, or before coming with the overall ionic equation. So the first thing, okay, I will actually solve by using the electrons, Fe2 plus to become Fe3 plus, lose 1 electron. So I put plus electron over there, Fe2 plus lose 1 electron. And here, okay, Mn and Mn, they are the same, so it's still okay. I need to actually make sure the oxygen, okay, to be appearing on my right hand side. So the oxygen, as I mentioned to you earlier, oxygen appears in form of water. So if you're wondering why there is no hydrogen over there, so the acidified, okay, will actually help out over here. The hydrogen will come in form of hydrogen ions, okay, because of the acidified potassium manganate. So if we want to balance now, so we have 4 oxygen here, so I put 4 there, and that makes my hydrogen becomes 8, so I put 8 over there. And then the last part that I need to do, okay, in order to solve this is going to be making sure that my overall charge left and right are the same. So 8 times 1, so plus 8. And this is negative 1, so plus negative 1. My overall charge is plus 7. And here 1 times 2 plus, so plus 2. 4 times 0, okay, water, the charge is 0, so I'm going to have plus 2. So the only way to make them balance is by adding electrons. Electrons are negative 1, so you just need to take the one that has higher charge, okay, in this case on the left hand side. So I'm going to actually add a certain number of electrons so that I have positive 2. So in this case I will add 5 electrons. So when I add 5 electrons, it's minus 5, yeah. So I'm going to get plus 2. So left and right, they are the same. So that makes that our half equations completed. So the last part that we need to do is to add both equations together. But we need to make sure that the electrons, okay, are being cancelled. So if you look at equation number 1, okay, there are only 1 electron. Equation number 2, there are 5 electrons. So I need to make sure that I have the same number of electrons. I times this by, I multiply this by 5, okay. So when I add, okay, the 5 electrons on my left hand side here and right hand side, they will cancel. So I am going to get, okay, 8H plus 5Fe2 plus MnO4 minus to give me, okay, the 5 electron will be gone, 5Fe3 plus Mn2 plus 4H2O. And this is going to be my overall ionic equation. Okay, so I have given you 2 examples here on how to balance redox reactions, especially when we are dealing with dichromate and permanganate. I hope this is helpful. Okay, and if you're not my students and you like my video, please consider subscribing and hit the like button. Thank you guys. See you. Bye.